So let's begin with the definition of a rate. A rate is a special ratio in which the two terms are in different units. Right? And it helps to see that with an example. It says, for example, if a 12-ounce can of corn costs 69 cents, the rate is 69 cents for 12 ounces. So basically what is happening with the rate is that we are making a comparison between two numbers, in this case the 69 cents and the 12, and those two numbers need to have different units. So the 69 is in terms of money, in terms of cents, and the 12 is in terms of ounces. So you're comparing the two numbers that have different units. When we talk about a unit rate, we're talking about a rate that is expressed as a quantity of 1. For example, 2 feet per second. We know that the 2 feet is related to this 1 second. Or if we're looking at 5 miles per hour, we know that 5 miles is related to this 1 hour. So anytime you have a rate where you have it expressed as a quantity of 1 second, or 1 hour, then you're talking about what's called a unit rate. So let's look first at finding some unit rates. Our first example says a cereal company purchases 3,000 metric tons of barley for $369,150, and they're asking us to find the unit price for US dollars per metric ton of barley. Now, what I typically tell my students with unit rates is to look for the word per. Now, it's not always in every problem, but it's in a lot of them. If you see the word per, that means division. And then look at what is in front of the word per and what is behind the word per. So in front of, we have US dollars. And behind it, we have metric tons of barley. So when I set up this unit rate, what I'm going to do is I'm going to take the quantity that's in front of the word per, and I'm going to put that on the top of a fraction. Remember, the per means division, so here's the per. And then we're going to write down what's behind the per. So this is metric tons of barley. Now I'm going to go into my problem and I'm going to get the numbers. So it says the cereal company purchases 3,000 metric tons. So does that go in the top or the bottom? The metric tons is in the bottom, so the 3,000 is going down here. And we know that they pay $369,000, or $369,150, and that's dollars, so that's going to go on the top. All right, and then we're going to divide that out. All right, so I'm going to go to my calculator and I'm going to type in the 369,150, press the divided key, and then type in the 3,000. All right, and so my unit rate, my unit price is $123.05 per ton. All right, let's look at the second one. If a coffee company sells 20 pounds of a coffee blend for $76.60, then what is the unit price for US dollars per pound of coffee blend? All right, so again, we know that the word per is going to be the dividing line in the fraction. We'll look to the left of that and we see that we're talking about US dollars. And to the right, we're talking about pounds of coffee. So I'm going to set up that rate by putting the dollars on the top because it comes first. The dividing line, which is the word per, and then the pounds of coffee. All right, let's fill in the numbers. If a coffee company sells 20 pounds, so where does the 20 go? 20 pounds, that would go on the bottom of a coffee blend for $76.60. The dollars goes on the top. Then we're going to divide. 76.60 divided by 20 gives me $3.83 per pound. All right, let's look at a couple of other examples. If Simon can run 4 miles in 36 minutes, there's a typo right there, that should say in 36 minutes, then what is the unit rate for how fast Simon can run in miles per minute? All right, so again, we have the word per. We have miles in front of it and minutes behind it. So let's set up our rate. Miles on the top. The per is the division line. And minutes on the bottom. Plug in your numbers. Simon can run 4 miles. So where does the 4 go? Top or bottom? It's going to go on the top. That's where the miles are. And then he can do that in 36 minutes. So we're going to put the 36 on the bottom with the minutes. We're going to divide that out on our calculator. So he runs, we'll do 2 decimal places. He runs 0.11 miles per minute. And that is our unit rate. All right, the last one we're going to look at says if a theater sells 240 tickets for a production over the course of 4 days, then what is the unit rate for the number of tickets sold for the given production per day? All right, so what's to the left? Let's look. What is the unit rate for the number of tickets sold for the given production per day? So we want, the first thing we want number of tickets. That's going to go on the top. And then the days goes on the bottom. So plug your numbers in. The theater sells 240 tickets. So the number of tickets, remember, is on the top. Over the course of 4 days, the days are on the bottom. And so now we will divide that out. That gives me 60 tickets per day. Now, once we get fairly skilled at finding a unit rate, the main reason that we would want to be able to have a unit rate is so that we can draw some comparisons. So let's look at an example where we are comparing unit rates. So a store offers 5 pounds of peanuts for $9.40, or 8 pounds of peanuts for $14.08. Calculate the unit rate in dollars per pound of peanuts. Okay, so this is important right here. Here's the word per that we were looking for. We have dollars in front of it and we have pounds behind it. And we want to determine which offer is the best deal for the customer. So remember that we're going to set up our rates by doing dollars on the top. The per is the division, and pounds on the bottom. All right, so let's begin with the 5 pounds of peanuts for $9.40. So we'll look at this part first. So the dollars goes on the top, so that's going to put the $9.40 on the top. And the pounds goes on the bottom, so the 5 is going to be on the bottom. All right, so let's divide that out. $9.40 divided by 5. All right, so this one is $1.88 per pound. All right, so our next one is 8 pounds of peanuts for $14.08. All right, so that would be, again, dollars over pounds. So $14.08 on the top, and the pounds is 8 pounds. And so we'll divide that out. 14.08 divided by 8 gives me $1.76 per pound. All right, and then you want to look at the two and make a comparison. So what is the better deal? Well, when we're shopping and we're buying things, we want to buy the one that is cheapest. So it is cheaper to buy $1.76 a pound than it is to buy $1.88 a pound. All right, and so this is our better deal. All right, let's try one more of these. So Clint drove 141 miles in 3 hours, and Leah drove 78 miles in 1.5 hours. We want to calculate the unit rate in miles per hour. Okay, so here we go with the word per. That's going to help me. We've got hours behind it and miles in front of it. So I know that when I set up my rates, I'm going to do miles on the top and hours on the bottom. So we want to calculate the unit rate for each trip to determine which person was driving faster. All right, so let's begin with Clint. Clint drove 141 miles in 3 hours. So for Clint, we're going to put the miles on the top, so 141, and the hours on the bottom. And we're going to divide it out. 141 divided by 3, he is driving 47 miles per hour. All right, let's do the same thing for Leah. Leah drove 78 miles in 1.5 hours. So let's calculate her rate. Again, miles on the top, so 78 on the top, over the time on the bottom, so 1.5. So 78 divided by 1.5, she is driving 52 miles per hour. And so again, the question is asking us who is driving faster. And so we can see that Leah, since she's driving 52 miles per hour, she is driving faster.